Hello, class. So this is going to be the last video on section 4.7. So we were looking at three different types of expressions which we can rewrite as an appropriate indeterminate, which was either 0 over 0 or infinity over infinity, right? So 2 videos ago, we saw how to deal with the form 0 times infinity, right? We rewrite one of the factors in that way that I showed you. In the previous video, we saw when we have something of the form infinity minus infinity, we factor out the simplest term of the difference, and then hopefully we get something that looks like 0 times infinity. Now for the last term, it's actually for the last type of problem, it's actually something that you already know how to do. Okay. So here I have three problems. I'm only going to go over part A because it's the same process for each one of these. Okay. So the other two, B and C, you can do for practice or as an exercise. Okay. So let's start. Say we want to find the limit as x approaches 0 of 1 plus 4x times 3 over x. Now, we've actually already seen a long time ago in chapter 1 or 2, I'm not exactly sure. I think chapter 2, that's where we started. We saw how to deal with limits like this. So this is something that looks like a function to the power of a function. When you have something like this, you can't just plug in the x value of the limit. You can't do that. So what was the thing that we did whenever we had something like this? Well, the trick, and it's fine if you don't remember, we're going to go over it here again. The trick was, instead of working with this limit directly, you're going to rewrite it. How are you going to rewrite it? You're going to take the natural log of this here. Of this. And that's the trick. That's the third form. Whenever you have something like this, a function to the power of a function, what you're going to do is take the natural log of that expression. So here, we're going to take the natural log of 1 plus 4x to the power of 3 over x. And the reason of doing this is because of the nice property of natural logs that we talked about before, that whenever you have something inside the natural log that's being taken to some power, you can bring that power outside. Right? Meaning that this is the same as, okay, bring the power outside, and you're left with this. And this is the last type of a problem that we're going to be working with. So this is part 3. Whenever you have something that looks like a function to the power of a function, what you do is you take the natural log of that expression before you work with the limit. Okay. Now that we've done this, what do we do next? Well, instead of working with this limit, we're going to work with this other limit of this thing that we just rewrote. Now, obviously, these two limits are not the same. Right? But what's happening is, since we took the natural log of this function, that was the first thing we did. Once we find what this limit is, whatever that is, let's say we get 5 as the limit, what's going to be the limit of the original problem? Well, you take the exponential of that. And the way I remember that is, I took the natural log at the start. How do I undo a natural log? I take the exponential. So that's what we do with problems like this. You rewrite it by taking the natural log of the expression, solve that different limit, and then take the exponential of that, and that's going to be the original limit you were looking for. So that's the idea. So let's go ahead and solve it. Right? So let's move to another page here. So we're trying to solve the limit as x approaches 0 of 3 over x times the natural log of 1 plus 4x. Now here we could do two things, right? It's a product, right? You can see that it's a product of two factors, right? 3 divided by x and natural log of 1 plus 4x. So we could check whether this is in the form 0 times infinity and then do that trick where we rewrite one of the factors. Okay, we could definitely do that. Instead, what I'm going to do is a trick that I showed you a couple videos ago that saves basically one step, because we can immediately rewrite this as an indeterminate by remembering that whenever you have a product of things, and in that product you have a division, that's the same as dividing the whole thing by that. Meaning that even though I'm just dividing the 3 by x, since I have a product of terms, it's the same thing as dividing the whole thing by x. meaning that the order in which you divide doesn't matter, right? In terms of what you studied in algebra, you would say that that division is commutative and associative. Doesn't matter in which order you divide. So you can just write it without loss of generality. You can divide everything by x. Now notice that this saves a step because this is already in the indeterminate form 0 over 0. Because if we take the limit of the top, what do we get? So let's see what we get. Limit as x approaches 0 of 3 times the natural log of 1 plus 4x divided by the limit as x approaches 0 of x. Well, this one on the bottom is definitely 0, right, obviously. Notice, again, I can't write equality because when any time you have a 0 on the denominator, you can't actually do this, right? So these limits aren't actually equal. I'm just trying to check that the form is correct. Okay. So the form on the bottom, we get 0. Now, what's the limit of the top? We don't have to worry about the 3. Right? We can move it's a constant. We can move it outside. Okay. Now, the natural log of 1 plus 4x. Well, as long as the function is continuous, the natural log is continuous, I can move the limit inside. Okay. So if I move the limit inside, I have the limit as 1 plus 4x. That's just, well, 1 plus 4 times 0. That's 1. Natural log of 1 is 0. 0 times 3 is 0. Okay. So basically what I'm saying is, because the natural log is continuous wherever this limit is, I'm saying that the limit as x approaches 0 of natural log, and we saw this before, of 4x equals the natural log of the limit. Which equals the natural log of 1, which equals 0. And again, 0 times 3 is just 0. So there we have it. We have 0 over 0. We have the correct indeterminate. We can go ahead and apply L'Hopital's rule. Now remember that for L'Hopital's rule, this is an actual equality, right? This limit that we're working with originally is the same as the limit of the derivative of the top divided by the derivative of the bottom. Okay. So derivative of the bottom is just, well, derivative of x is just 1. That one is easy. How do we deal with the derivative of the top? Well, the 3 is a constant. We can just move it outside. And then for the natural log of 1 plus 4x, well, you need the chain rule. The outside function is natural log. Inside function is 1 plus 4x. Okay. So you take the derivative of the top, of the outside function, sorry. That's 1 plus 4x, because you leave the inside the same. Multiply by the derivative of the inside. The derivative of 1 plus 4x is 4. So when you simplify all this, what are you left with? Well, the limit as x approaches 0 of 12 divided by 1 plus 4x. Because when we divide by 1, that's itself, right? So we can just get rid of that 1. And this you can evaluate directly. Limit of the top is 12. Limit of the bottom is 1. So this limit is 12. Now, of course, again, this is not the original limit. It's this limit. So again, the last thing to remember, once you solve that limit, how do you get back to the original one? You just take the natural log, the exponential, to undo the natural log that we did at the start, right? So the original limit is going to be whatever we found here, but you take the exponential of that. So exponential of 12. And that's the answer. So those are the 3 types of problems we're going to see. Right? So again, either 0 times infinity, infinity minus infinity, and a function to a function. So in the case of a function to a function, just evaluate the limit as you would before, right? In what we did in chapter 2, that you first take the natural log, and then you find this new limit. So again, it's not the same limit, but once you find this one, you can just take the exponential of that, and that's going to be the original limit you were looking for. And those are the 3 types of problems we're going to see. Right? And again, when you see problems like this, some might be a little bit more complicated, but you should always start. So you see part B and C, they look like a function to the power of function, always to the natural log first and work from there. You should always, after you take the natural log, you should always end up with something that looks like 0 times infinity or infinity minus infinity, and you go from there. So again, you can do the other exercises, the other problems, part B and C as an exercise, and let me know if you have any questions on that.